Welcome to this session. We will be continuing with the radiation from an electric current source, the spherical wave components for the radiated fields. Last time we investigated the magnetic field components and we saw that both the HR, the radial component, and the elevation component, which is the H theta component of the magnetic field, are 0. The magnetic field has only an azimuthal component or H phi. Next, we will investigate the electric field components radiated by the current source. Let us go to the lecture. Now, in order to find the electric field components, we need to look again at equation number 1, and for calculating the radiated electric field, we need to calculate divergence of A and grad of divergence of A for the spherical wave. So, let us do that. So, divergence of A is 1 by r square sin theta del r square sin theta A r plus del theta r sin theta A theta plus del phi r A phi. And that is equal to 1 by r square sin theta. We substitute the value of A r, A theta and A phi. So, del r square sin theta I L by 4 pi r e to the power minus j k r cos theta plus del theta r sin theta times minus 1 I L by 4 pi r e to the power minus j k r sin theta plus 0 because A phi is 0. And that is equal to 1 by r square sin theta I L by 4 pi sin theta cos theta del del r of r e to the power minus j k r minus I L by 4 pi e to the power minus j k r del del theta of sin square theta. And that becomes equal to one by r square sin theta I L by 4 pi sin theta cos theta r minus j k e to the power minus j k r plus e to the power minus j k plus e to the power minus j k r. Minus I L by 4 pi e to the power minus j k r to sin theta cos theta. And that is equal to I L by 4 pi e to the power minus j k r minus j k r by r square plus 1 by r square minus 2 by r square cos theta. Which can be further simplified as divergence of A is I L by 4 pi e to the power minus j k r minus j k by r minus 1 by r square minus 1 by r square times cos theta. We call this equation 9, and then we proceed to calculate grad of divergence A. And then we proceed to calculate grad of divergence A. And that is equal to AR del R IL by 4 pi e to the power minus j k r minus j k by r minus 1 by r square cos theta plus 1 by r a theta del theta IL by 4 pi e to the power minus j k r minus j k by r minus 1 by r square cos theta plus 1 by r sin theta a phi a phi del phi IL by 4 pi e to the power minus j k r the same thing j k minus j k by r minus 1 by r square cos theta. So, let us call this 10. This is by the definition of the gradient operation in the spherical coordinate system. Okay. So, now we know that from equation 1 E is equal to minus j omega mu A plus 1 by j omega epsilon grad of divergence A. Grad of divergence grad of divergence A. Okay. So, E r, therefore, the r component of the electric field will be equal to minus j omega mu A z cos theta plus 1 by j omega mu the r component of grad of divergence A, which we derived before, which is del r I L by 4 pi e to the power minus j k r minus j k by r minus 1 by r square times cos theta. And that is equal to minus j omega mu, substituting for A z I L by 4 pi r e to the power minus j k r cos theta plus I L by 4 pi 1 by j omega epsilon minus j k cos theta del r will work on e to the power minus j k r pi r minus I L by 4 pi 1 by j omega epsilon cos theta del r is going to work on e to the power minus j k r by r square. And that will give rise to minus j omega mu I L by 4 pi r e to the power minus j k r cos theta plus I L by 4 pi 1 by j omega epsilon minus j k cos theta times minus j k by r e to the power minus j k r minus 1 by r square e to the power minus j k r. For the first term, for the second term, and then for the third term minus I L by 4 pi 1 by j omega epsilon one by j omega epsilon cos theta minus j k by r square e to the power minus j k r minus 2 by r cube e to the power minus j k r. This can be further simplified as E r equal to I L by 4 pi e to the power minus j k r cos theta times minus j omega mu by r plus 1 by j omega epsilon times minus j k times minus j k by r square minus 1 by r square minus 1 by j omega epsilon minus j k by r square minus 2 by r cube. And this can be further written as I L by 4 pi e to the power minus j k r cos theta times minus j omega mu minus j omega mu by r minus k square by r 1 by j omega epsilon plus j k by j omega epsilon 1 by r square plus 1 by j omega epsilon j k by r square plus 2 by j omega epsilon times 1 by r cube. Since now k square by j omega epsilon is omega square mu epsilon by j omega epsilon, that is equal to minus j omega mu E r can be written as I L by 2 pi e to the power minus j k r times cos theta k by omega epsilon times 1 by r square plus 1 by j omega epsilon r cube. Now, since k by omega epsilon equal to omega root mu epsilon by omega epsilon equal to eta, which is root of mu by epsilon, the intrinsic impedance of free space, we can write the value of E r as I L by 2 pi e to the power minus j k r times cos theta eta by r square plus 1 by j omega epsilon r cube. So, this completes the derivation of the radial component of the electric field radiated by the electric current point source. Now, for the theta directed electric field, we have that equal to j omega mu a z sin theta plus 1 by j omega epsilon 1 by r del theta I L by 4 pi e to the power minus j k r times minus j k by minus j k by r minus 1 by r square times cos theta So, this is the theta component of grad of divergence of A times 1 by j omega epsilon. So, this is the theta component of 1 by j omega epsilon grad of divergence of A. And that now on substitution of A z becomes equal to j omega mu I L by 4 pi r e to the power minus j k r sin theta and we need to do just this theta differentiation and we need to do just this theta differentiation. Plus 1 by j omega epsilon 1 by r I L by 4 pi e to the power minus j k r minus j k by r minus 1 by r square times the differentiation with respect to theta, which is minus sin theta, times the differentiation of cos theta with respect to theta, which is minus sin theta. And then combining the terms together, we have and then combining the terms together, we can finally write E theta as I L by 4 pi e to the power minus j k r j omega mu by r plus eta by r square plus 1 by j omega epsilon 1 by j omega epsilon r cube times sin theta. So, this is the expression for E theta. Finally, E phi is 0 because A does not have any component along the phi direction. So, the first term of the electric field, which is minus j omega mu A, that is 0, and the second term, if you look at the expression for grad of divergence of A, if you look at the second term at the third term, if you look at the third term of the grad of divergence of A, that is del del phi of this term. So, this term has no phi component. So, therefore, the phi component of grad of divergence of A is 0, and therefore, E phi becomes equal to 0. So, this completes the derivation of the 3 electric field components radiated by the point current source. Okay. We note that E phi is 0 and the electric field is along the radial direction and the theta direction. Okay. So, we conclude this lecture. Next, we are going to go to the magnetic current source. Thank you.